Hassler here. I'm going to work through the 9.2 Explore, finding a correlation. So yesterday we plotted data and found the line of best fit. Some data sets show a positive linear relationship and other data sets show a negative linear relationship. Sometimes the data points are all very close to the line and other times the data points are more spread out. Today we are going to explore a way to describe the spread of the data using a correlation coefficient. So I just want to go back to our example yesterday. And when I look at these dots, these data points on this graph, some of the data points are really close to that line. For example, when I look at these data points right in here, these are all really close to that line. And then when I get further out, I got data points here and here that are further from the line. And so we can use something called a correlation coefficient to help describe how close or how far away the data points are from that line of best fit. And that's what we're going to work on today. In order to do that, we're going to do a 9.2 Desmos activity. And so I have that here for us. And this is the biggest lie I tell myself is I don't need to write that down. I'll remember it. And that's not true. And so what you're going to do is you're going to log into the Desmos activity. The next slide talks to you about a scatter plot. That's what we did yesterday. Line of fit is a line that is drawn on the scatter plot to make predictions. The line of best fit is the calculated line. That's what we found yesterday. A correlation coefficient, or R, we're going to use the letter R for that, is a calculated number that tells us how well the data fits the line, whether the data is really close to or far away from that line. And so that's what we're going to explore. We're going to explore the line of best fit along with this correlation coefficient. So you're going to work through a series of slides. I'm going to do this first slide with you, and then I'm going to get some notes down. But in this slide, it says grab the points on the graph and move them until the R below. And so they're talking about this R right here, okay, which represents this number. Until the R below is a positive 1/2. You'll get a message when you're close enough. Okay, so to move the data points, you just pick a data point and you move it around. And notice that as you move your data point around, this R value here is moving. And you can see as I move it, this little picture pops up. It says close enough. I have an R value of 0.5018192434454, about 0.5. And so what I'm going to do is I'm going to take this picture that I have. I notice that I have this line going halfway between the data. I've got 3 data points above, 4 data points below. It is moving in a positive or increasing motion. And my data points aren't super close to the line, but they're also not like really far away from the line. So what I'm going to do is I'm going to go to my lesson and I'm going to find the spot where I have this R value of 0.5, and I'm going to put this picture on my notes. So if we come back over here, I have this number line here, and my number line goes from -1 to 1. And so here is 0.5. So I've got to move my screen so that I can see that. And I'm going to go ahead and draw my line of best fit first. We had something, let me head back here. We had something that looks like this. And then we had some points above. So we got 1, 2, 3 points above, 4 points below. So something like this, okay? And this would be an R value of 0.5. And so then I'm going to click the next slide after I copied that down. And, sorry. So sketch this graph in your notes, did that. This is a moderate positive linear correlation. So I'm going to come back over here and I'm going to write that in there. This was a moderate positive, my line is increasing. I have a positive slope, linear correlation. And correlation is just another word for relationship. Correlation. I have this word relation in correlation. It's talking about the relationship between the data points. In fact, I'm going to do this for all 5 of these, okay? And so as you move throughout this Desmos, you'll see that, you'll see now it's going to ask for a positive 1. And so you're going to move these around until you get a positive 1. And then it's going to talk to you about what that is called. And then it asks for -1/2. And then it talks to you about what that's called, and a -1, and it talks to you about what that's called, and then a 0, and it talks to you about what that is called. And so you're going to go through and work through each of those, okay? When you're done, you should get something that looks like the following. So I'm going to pause the video, I'm going to put these pictures in, and then I'm going to unpause. When I pause the video, I want you to go finish those slides that works through the R value of 0, and then go back and click play on the video and see if your slides are similar to mine. All right, I'm back. And so you should have something that looks similar to mine. Notice that with an R value of 1, so I went ahead and labeled each of these. With an R value of 1, my data points are on the line. Actually, an R value of 1, your data points should form a straight line. You probably had R values that were like 0.99, which means you might not have had a perfectly straight line, but close enough. This is called a perfect positive linear correlation. We did an R value of 0.5 together. Notice that the data points are further away from that line. When we had an R value of 0, notice that I cannot tell whether the data is increasing or decreasing. We get this R value of 0, meaning that there's no relationship. The data points are far away from the line. Again, I can't tell if it's a positive or negative slope, whether the line is increasing or decreasing. So no correlation. Notice the further we get away from 1, which was perfect, the more spread out that data becomes. And I'm going to keep moving now down into the negatives. We had negative 0.5. And this time my data is decreasing. And that has the R value being negative, that negative slope. This is not the slope value, but because the line is decreasing, my R value is negative. And the data is not super close to the line. Versus an R value of -1. Again, the R value is negative because my data is decreasing. This would be a perfect negative linear correlation where the data points are forming pretty much that straight line. And so we range from -1 to 1 when it comes to R values. And these R values, again, are used to describe how close the data points are to the line. The closer to the line, the closer to 1 or -1 that R value is going to be. The further from the line that those data points are, that means I'm moving in towards 0. Okay? All right, let's take a look at another idea. So your job then is to finish this Desmos. Okay, so you're going to work through this Desmos. The range of the correlation coefficient we just said was -1 to 1. It says sketch a line of best fit. And so you're going to click this tool right here so you can draw a line in. You want to draw a line so that your data is about half above, half below, and moving in the direction of the line. I think I could have done a better line, so I'm going to hit this arrow here to undo, and I'm going to try again. There we go. And because this data is not super close to the line, and because my line is increasing, I believe this is a R value of 0.5. And so they say, good work. Here's the line of best fit with an R value of 0.5. So you're going to finish working through these slides. When you're done, you're going to come back and you're going to take a look at problem 2. So let's look at that together. It says a store manager records the total visits and sales in dollars for 10 days. The data are shown in the scatter plot. Sketch a line of best fit and estimate the correlation coefficient. So in class, I gave them straight edges to draw in that line of best fit. I think this looks pretty good. And the R value, I think the R value would probably be 0.9. The data points are not perfectly all touching the line, but I have a lot of data points that are really close to that line. So 0.9 would be a pretty good fit. It says describe the relationship between the number of visitors and the sales. So when the number of visitors increases, the sales is also increasing. Both are positive relationships. So I'm going to say as the number of visitors increases, the total sales increases. And this happens because we have a positive linear relationship. And so I'm just going to make a note here. Because this is a positive linear relationship, we end up having an increase in both visitors and sales. It says, what conclusion can the store manager draw based on the data? So A says an increase in sales causes a decrease in visitors. Well, first of all, there is no decrease in visitors, and so I'm going to scrap this one. B says an increase in visitors causes an increase in sales. Yeah, there is an increase in visitors and an increase in sales, but the word causes means that the only thing that is making my sales go up is my number of visitors. And I can't be certain about that. There could be other factors that could be playing a part in this. I'm going to say other factors, question mark. So I'm going to move on and read the others. An increase in sales is correlated with a decrease in visitors. Well, there's no decrease, so it can't be C. An increase in visitors is correlated with an increase in sales. Here we go again, an increase for both, but I have this word correlated. And correlated means related, correlated, related to each other. And this is the choice that we're going to go with. It's always correlated, never causes. Causes implies that there's only one reason that this change in the variable is occurring. The only reason total sales is going up is because the number of visitors is increasing. And that might not be the only reason. It could be the season. Maybe it is seasonal, or maybe there was a sale, or maybe the sale was over. That's the problem, right? And so there are other factors that I think could play a role in this. So it's never causes. So let's go take some quick notes, okay? And so, again, your job was to finish that Desmos. A couple of things we're going to talk about in the quick notes is the correlation coefficient. And the correlation coefficient is R. And this tells us, so this is a calculated number, that tells how well the data fits the line. We say that this can be anywhere between -1 to 1, where -1 and 1 are perfect. And 0 is no correlation. So the closer to 0, the more spread out that data is. Okay, the other thing I want to say is that this R value gives you direction. So it can either be positive or negative. And then again, the closer to -1 or 1, means that your data is closer to the line. All right, and then you can never claim that one variable causes another variable to happen. Never claim one variable causes another to happen. We say always correlates. All right, so your job is to work through these last few problems. This would be like your check your understanding. You have one set of problems where you have to, where you have to match the R value with the description. And then in problem 2, you are given data about a Honda Civic. The data is in the table, and there's the data for a graph, and then you have to answer some questions. If you have questions, let me know.